Welcome back all the viewers to this session. In this session we are going to discuss about the generations of computer. Before we start discussion about the generations of computers, so let us recall what we have discussed so far. So in the previous session, so we have been discussing about the early computing devices, so which are used in doing calculation. So basically they are mechanical in nature, and we have seen many devices have been used in different time intervals, so by man to assist in his calculations. So few of them includes the abacus, so which was found so in around 500 BC. That was the first calculating tool, so which was used by man. So next we have the Napier bones, so which was developed by the mathematician called John Napier in 1617. So which was again a simple tool, so made up of several bones, and each bone is marked with the numerical digits. So by using which, so you can carry out many calculations of mathematics. And also we have seen the Pascaline, so which was a mechanical, purely mechanical device, so constructed with the help of the moving parts like dials and wheels, toothed wheels, and it was basically automatic machine, so which was able to do the calculation like addition and subtraction. So that was developed by Blaise Pascal in 1642. So next we have the modified Pascaline, so that was stepped reckoner, so which was developed by Gottfried von Leibniz, so by modifying the original Pascaline. And also it can carry out the along with the addition and subtraction, so it can do multiplication and the division as well. So next we have the difference engine, so which was a highly developed mechanical engine, so which was developed by Charles Babbage in 1822, and this difference engine so was able to carry out the problems of the differential calculus, so which was which based on this model. So in this model the Charles Babbage has proposed almost all the parts, so which have been which are included in the modern day computers. So because of this, so the Charles Babbage is referred as the modern day father of modern day computers. And then we have the analytical engine, that again it was developed by Charles Babbage in 1833, so which was run by a steam engine and includes many parts, so which resembles today's computers, and it was developed to perform the problems of analytical mathematics. And then we have the census tabulating machine, so which was developed by Hermann Hollerith in 1884, so which was used for doing for processing the census data of America in 1884. So these are the few devices, mechanical devices which were developed. So before we come with the actual electronic computers, so in 1945, and so before we develop the actual electronic device, so man was using all these devices in doing the calculations. So these are the things we have studied so far. So now we will come to the generations of computers. So the actual electronic era so will begin from the year 1945, so with the launch of the first operational electronic computer called Mark First, so in 1945. Before this, so many projects were going on to develop the electronic devices, electronic computers. So, but it was not successful. They were not successful in constructing the computer. So, but in 1945, the team headed by John Mauchly was able to design a computer, working model computer called Mark First. So, with that, the electronic computer have begun, and it's been developing very fastly and taking part in all the activities of human being. So, based on in the development, in the evolution of computers from 1945 to till date, so many changes and many developments in both hardware and software technology have been taken place, and different components so being used in constructing the computers, so in the evolution of computers. So in the first, based on this technology, so based on the hardware technology being used and the software technology being used, the evolution of computer is divided into 5 major generations. So first generation computers, second generation computers, third generation computers, fourth generation computers, and fifth generation computers. So the first generation computers will begin from 1945 and ends in the year 1956. The second generation computers will begin in 1956 and ends in 1963. And third generation computers, which begins in the year 1964 till 1971, and the fourth generation computers will begin in the year 1971, and it is being used till date. So the present what we are using belongs to the fourth generation computer. And finally, the fifth generation computers are being used presently, and it's still in its infancy stage, and only few of the properties of the fifth generation is being developed so far. So you may see the fifth generation computers in future. So let us discuss the 5 generation computers in detail one by one. First generation computers. So the first generation computers, so where you can see the first generation computers between the year 1945 to 1956. The major features, the characteristic features of these first generation computers are being use of the vacuum tubes for internal circuit, magnetic drums were used for memory, punched cards were used for input and output, low-level languages for programming, processing speed was very low, so that is in terms of milliseconds. So systems were not much powerful, and systems were huge, non-portable, and expensive. So these are the important features of the first generation computers. So vacuum tubes. So vacuum tubes are it's a electronic component, so which was invented around in 1940s. So which was used like a switch. So which is the basic element in developing the binary circuit. So binary circuits are being used by the switches, so which is the basic component being used in first generation computers. And for the construction of memories, so the magnetic drums were used, and the punched cards. So the punched cards were used for carrying out the input and output operations, and for programming purpose, the low level languages. So the also called the machine level language is being used, which is a binary language, so which will have the machine instructions, so which is consisting of the zeros and ones, and it is very cryptic, and it is very difficult to understand. The processing speed of these first generation computers were measured in milliseconds. So 1 millisecond is 10 to the power of minus 3 of a second, 1 millionth second. So 1 millionth second is called a millisecond, and it is very slower, so compared to today's computers. And the systems were not very powerful, so they can perform only few calculations, so such as the addition, subtraction, multiplication and division. So only these very nominal mathematical calculations could be able to do with these computers. And the systems were very huge and non-portable and expensive. So basically the computers developed in first generation computers, so they are not for the commercial purpose. So they were developed for the research purpose, and it is very expensive, so the common person cannot afford. So the computers were cost around several crores, 100 to 200 crores of dollars. So they are very much expensive and also very huge. So the first computer, that was ENIAC, so which is the first operational computer which is installed, and it is being occupied the area of half of the football ground. So that much big it was, and because of this huge size, so it was not able to carry to different places. So it is fixed in a fixed place. So it is kept in a fixed place, and it could be work there. So few examples of the first generation computers were ENIAC, EDVAC, UNIVAC, Z3, Mark First, etc. So these are the examples so for first generation computers. Okay, this is the picture of vacuum tubes, so which is being used as a main circuit element in the first generation computers. So it almost resembles like a bulb, so which is used in today's automobiles. So automobile, that is cars and many other four-wheelers. So it resembles almost the, and also it will have the same almost the same size of the bulb. So that is the main component, so which is being used in construction of the circuit. And this is the picture of punched cards. So the punched card is nothing but a paper card, so on which the holes are made to represent the zeros and ones. So the no hole area is referred as 1, and the area with hole is referred as the 0. So with this convention, the data is stored in this punched cards. So these were the primary storage and input and output media in the first generation computers. So this is the picture of the ENIAC, so that is electronic numerical integrator and computer, so which was produced by US government, and it was developed in the University of Pennsylvania. And the persons who are involved in the development of this computer was J.P. Eckert and J. Mauchly. And it consisted of around 18,000 vacuum tubes to develop the logic circuit, and also magnetic, it includes magnetic drum memory, and it was consisting of 70,000 resistors and 5 million soldered joints, and several kilometers of wires being used in constructing this computer. So in the picture you could see how big the computer is. So the man and the woman are actually it looks like they are they are roaming around the computer. So the whole background what you see is the complete system. That much big it was, and so when it is working, so when the computer is working, so it was consuming around 160 kilowatts of electrical energy. So that was the first operational computer, ENIAC, so which was developed by the University of Pennsylvania. So this is the picture of electronic discrete variable automatic computer, that was HAVERI. So HAVERI is another important first generation computer, so which is again based on the vacuum tube technology, and it was designed by the person called John von Neumann. So he is a very important person, so who proposed the concept of stored memory concept. That means, so the program, so which has to be executed or run, so it should be completely stored in the memory, and also it should have the facility called conditional control transfer. So that means, so the execution of the instruction so need not be in a linear fashion. So the condition, it should be able to change the execution order by unconditionally transferring to the required place. So that is conditional control transfer. So this is the concept proposed by John von Neumann, and based on this concept, the modern day computers are being constructed. So HAVERI was a binary serial computer with automatic addition, subtraction, multiplication and division. So this is another important computer of first generation, UNIVAC. So that is a universal automatic computer, and it was developed by Remington Rand in 1951. Okay, so that is regarding the first generation computers. So next we have the second generation computers. So the second generation computers come into the picture in the year 1956. So with the invention of a transistor in 1951, which replaced the vacuum tubes, so which were the basic elements in first generation computer, and which is very efficient than the vacuum tubes. So transistor, or the electronic element, so which resembles almost the working of the vacuum tube, and it replaces it in second generation computer. It is very small in size compared to vacuum tubes, and it was very efficient than vacuum tubes, and also it was consuming less energy than the vacuum tubes. So because of this very interesting features, the transistors being replaced the vacuum tubes in second generation. So with this, the second generation computers were launched in 1956. So the major features, the important features of second generation computers include the transistors were used for internal operations, that is for building the internal circuit. The transistor is the major element, so which is being used, and the magnetic core was used for constructing the main memory, and also the magnetic tapes and discs were used for secondary storage. So secondary storage are being introduced, and they were constructed by using the magnetic tapes and discs. So many high-level languages such as COBOL, Fortran were introduced, and also before this, so in the beginning, the first half of the second generation computers, the assembly level languages were used, so which is less complex than the early machine level language. So assembly level language is more simpler and understandable than the machine level language. So later in the second half of the second generation computers, the high level languages were introduced and which were used in constructing the programs. So the less computational time, that is the time consumed by executing the instructions, were reduced to microseconds. So in first generation, so you could see the computational time was measured in terms of milliseconds. So but in the case of the second generation computers, so it is reduced to microseconds. So microsecond is 10 to the power of -6th of a second. So that is 1 followed by 6 zeros. If you divide a second, so with this number, so you will get 1 microsecond. So that is very much improved than the first generation computers. The systems were faster, powerful, more reliable, cheaper, and had much memory. So more memory it was having. Because of this transistor, the system was not producing much heat. So the very important drawback of the first generation was that so it was producing very much heat. The component being used, that is a vacuum tube, so it was very inefficient component. So it was producing almost 80% of this the power it was consuming, so it was converted to heat energy. So because of this, so the system failure was very frequent in first generation computer. So because of this transistor, is very efficient in, so it was almost utilizing almost 80% of the energy, so which is consumed being converted to useful work. So only 20% of it was wasting, which is very much comparable to the first generation computers. And the system was powerful, so it had more memory and more reliable. So because of this reduced generation of the heat, the system becomes reliable. So in the first generation, so because of this heat, the elements used to get melted, and the system become damaged. So this was avoided in the case of second generation computers. These are the important features of second generation computers, and the computers of this second generation includes Hangal 200, IBM 1401, CDC 1604, UNIVAC LRC. So these are the important computers of second generation. So this is the picture of transistor which replaced the vacuum tubes in the previous generation, so which is very efficient compared to the vacuum tubes. So it was utilizing almost 80%, so whereas the vacuum tubes were utilizing only 20% of the energy to do useful work. And also, so it is almost 10 times less larger than smaller than the 10 times smaller than the vacuum tubes. So this is IBM 1401 computer, which was developed by International Business Machines. So the important company in the field of computers. Okay, that's regarding the second generation computers. So now let's go to the third generation computers. So the third generation computer will begin in the year 1964 and ends in the year 1971. The major features of the third generation computers are the integrated circuit being introduced in developing the circuits, which incorporates many transistors. So transistors into one single chip, that is called the silicon chip and integrated chip, IC it is called. So the many transistors being incorporated within a single chip, and they are interconnected internally, and only the input and output lines are present outside. So the internal circuit is kept very securely within the silicon chips, and that is called integrated chip. So it is one of the major development in the field of electronics and computer. So that introduction of the integrated chips have changed the scenario. So it has it has brought a very drastic change in the development of computers. That is integrated chip is being introduced in the third generation computers, and you can see the introduction of mini computers in third generation. So earlier, so before the third generation computer, so we could see only very large computers but less efficient computers. So these mini computers are almost 100 times smaller than the previous ones. So that is mainframes. So the mainframes were being used in first generation and second generation computers, so which was very large, and it cannot be carried to different places so very easily. The mini computers were being introduced. So it was having the size of almost the size of an office table. So but the mainframe computers, so very large, so that should be kept in a large hall. So that is mini computers, and you could see the emergence of the software industry. So the software industry, the separate industry of developing softwares have came into a picture, and it has started emerging in the third generation computers. And I could see the reduced computational time. So that is, the computational time is measured in terms of microseconds. That is, microsecond is 10 to the power of minus ninth of a second. So that is called microsecond. So that was the speed of the third generation computers, and the operating system is being introduced. So earlier, so there was no concept called the operating system. So that means the handling of all the user programs has to be taken by the operator manually. So the operating system has removed this risk of managing the application programs, and it was able to run the application program, user programs easily. So that allowed machines to run many different programs once. So that is called multitasking. So many programs can be loaded onto the system, and it could be run at the same time. So all the programs could be run at the same time. So that is called multitasking. Multitasking is being introduced. System could be used for number of commercial applications. So because the introduction of mini computers, integrated circuits, has brought the drastic change in the design of the computer. So it has become very cheaper, many commercial companies could afford to buy a computer, and commercial applications have been developed. The systems were faster, more powerful, more reliable, cheaper, smaller in overall size, and had more memory. So these were the important features of third generation computers. And the example of third generation computers includes IBM 360 series, Honeywell 600 series, PDP-11, IBM 370/168 series, etc. So these are the important computers of the third generation. So this is the picture of integrated circuit which was developed by the person called Jack Kilby. He is an engineer from Silicon Industries, so which is a company, software company, computer industry in USA. The IC combines more components into single chip. As a result, the computers become smaller in size. So in a single IC, so you could include around 10 to 20 transistors, and they could be connected internally, and only the interface is provided through the circuit. So the input and to take the input, the processing will be done internally. So that is called a single IC. So the first IC, so which was developed, is which was having the SI, so LSI, large scale integration. So large scale integration. So with this technology, LSI technology, around 10 to 20 transistors could be incorporated within the single IC. So this is the picture of IBM 360 series computers. So that is regarding the third generation computers. So the fourth generation computers will begin from 1971, and it is being still used today. So with the introduction of the IC chips in the third generation computers, so by improving this IC, so with the technologies like LSI, VLSI, ultra ULSI, so that is ultra large scale integration. So the fourth generation computers have come into act in 1971. So more and more with the change in the technology, hardware technology, so more and more transistors could be incorporated with this IC within a single IC. So because of this, the development of computers has changed drastically. So with this, the fourth generation computers have been launched in the year 1971. The important features of fourth generation computers include more circuits on chips, so that is LSI, VLSI and ULSI. LSI is large scale integration, VLSI is very large scale integration, and ULSI is ultra large scale integration. And you could see the introduction of microprocessors. So it says microprocessors are nothing but a single IC which is being used as a entire CPU. So the job what the entire CPU was doing in third and second generation computer was replaced with a single IC chip. So that is a microprocessor. So because of this, the development of computers has become very faster, and the size of the computer has reduced to a considerable size. And the use of chips for memory. So in constructing memory, so you could also use in fourth generation computers the integrated circuits were used. So the computer networks and internet was developed. The cost of assembling is reduced to a great extent, so easily portable because of their smaller size. So with the introduction of this microprocessor, the size of the computer becomes very small, and it could be easily carried to different places. So here you could see the introduction of personal computers. So the personal computers will occupy the tabletop, so that it can be carried to any place easily. Hardware failures were negligible. So because of this IC technology, so the IC technology is very strong. So it cannot be, it was almost using the 95% of the energy and not producing much heat. So because of this, so it has become very stable, and so there is no hardware failures in the fourth generation computers. The systems were faster, more reliable, cheaper, smaller, and had more memory. So these are the fourth generation features of fourth generation. So this is the picture of IC, so which have discussed in the previous section, that is third generation. So these are the photographs demonstrating the LSI and VLSI design IC chips. So large scale integration, that is called LSI technology, so which incorporates almost 500 to 20,000 transistors within a single IC chip. So then more and more transistors are able to include within the IC. So that technology is called very large scale integration. So with this technology, around 20,000 to 1 million transistors could be incorporated within a single IC. So then we got the technology called ultra large scale integration. So that is ULSI. So more than 1 million transistors and up to several crores of transistors could be incorporated within a single IC chip. So because of this development in the IC technology, so the computer have become smaller in size, and it has become very powerful. Fifth generation computers. So the fifth generation computers are used presently, and they are still in developing stage. It is in infancy stage, so because it is not developed much. So the features of the fifth generation computers includes, so it will have completely new storage technology and advancement in network technology. So today, so we were in fourth generation computer, only the computers were able to interconnect together and share the data within them. So but in fifth generation computer, the computer will be able to communicate with almost all objects in the universe. So that kind of networking is possible with this fifth generation computers, and it incorporates superconductivity. It's a state, so where the conductor which is being used in constructing the circuit offers no resistance to the flow of current. So that is called superconductivity. And also we could see the development of supercomputers, very fast computers, and also we can see the concept of parallel processing, and they can make a judgment and decisions, that is artificial intelligence being incorporated in the fifth generation computers. And also we can see the development of robotics. So these are the important features of the fifth generation computer. So few of these features you could also already see in the recent developments. So many research are going on to develop these advancements, and later you could see the 5th generation computers fully implemented. Okay, that's regarding the 5 generations of computers. For further studies, you could these are the references, so you can refer to enhance your knowledge. The important ones are the book by V. Rajaraman titled Fundamentals of Computers, and Sanjay Saxena, a first course in computers, Vikas Publishing House, Pradeep K. Sinha and Priti Sinha, Computer Fundamentals, Generations of Computers in tutorials part on web, the 5 generations of computer, Webopedia. So these are the important references we can make to get further information. Thank you for watching, and keep watching for my studios videos. Thank you.